Here we are gonna find the cofactor matrix of A. To find the cofactor matrix of A, I follow this rule that says the element of cofactor matrix would be Cij negative 1 to the power of I plus j times determinant of the matrix, for example, matrix Mij. It is an order of this matrix. It shows matrix M would be obtained by deleting um, row I and column J. So I will follow it and write all the elements of cofactor matrix. So I say C11 should be here. So negative 1 to the power of I plus j, 1 plus 1 to the power of 2, and determinant of uh, determinant of a matrix that's obtained by deleting first row and first column, which is 4, 5 to 6, so 4, 5 to 6, and the answer would be 4 times 6, 24, minus 2 times 5 gives me 10, 24 minus 10, 14, and 14 times negative 1 to the power of 2, so would be positive, so would be 14. It's 14. Okay, I will go for C12. I am writing all the elements of cofactor matrix. So C12, that means negative 1 to the power of negative 1 to the power of 1 plus 2. So negative 1 to the power of 3, which is negative 1, and determinant of the matrix that's uh, obtained by deleting first row, second column, 1, 2, first row, second column. So I will have 0, 5, 1, 6. 0 times 6, 0 minus 1 times 5, negative 5, and times this negative gives me positive 5. I will go for the elements 1, 3. Elements 1, 3, I follow this rule. Negative 1 to the power of 1 plus 3, which is 4. So negative 1 to the power of 4 gives me positive 1. And times determinant of a matrix that's obtained by deleting first row, third column, which is 0, 4, 1, 2. So I have to say 2 times 0, 0 minus 1 times 4 would be negative 4, negative 4 times 1 gives me negative 4. So I will go for the next element that I have to find from second row I see C21 equals negative 1 to the power of 2 plus 1, 3, and negative 1 to the power of 3 gives me negative 1, and I have to find the determinant of a matrix that obtained of deleting second row and first column, which is 1, 3, 1, 3, 2, 6. So I have 1 times 6, 6 minus 2 times 3, 6, so would be 0. I will go for element 2, 2, which is negative 1 to the power of 2 plus 2, which is negative 1 to the power of 4. So it gives me positive 1. Determinant of matrix that obtain of second row and second column. So it would be 2, 3, 1, 6, which is 12 minus 3. And here I have positive 1. 12 minus 3 gives me 9. C, 2, 3. So I find negative 1 to the power of 2 plus 3, negative 1 to the power of 5 gives me negative 1, and determinant of the matrix that's obtained by second row, deleting second row and third column. So would be 2, 1, 1, 2. 2 times 2, 4 minus 1, 3. 3 times this negative 1 gives me negative 3. I will go for the last row. So C3, 1. C3, 1, negative 1 to the power of 3 plus 1, negative 1 to the power of 4 gives me positive 1. And determinant of a matrix that obtain of deleting second row, first column, which is 1, 3, 4, 5. So would be 5 times 1, 5 minus 12, which is negative 7. And I will go for the C3, 2, negative 1 to the power of 3 plus 2 would be negative 1 to the power of 5, which is negative 1. And times determinant of a matrix that's obtained by deleting third row, second column, so it would be 2, 3, 0, 5. 2 times 5, 10 minus 3 times 0, 0. So 10 times negative 1 gives me negative 10. And the last one would be C3, 3, which is negative 1 to the power of 3 plus 3, negative 1 to the power of 6. That gives me positive 1. And I will go to find the determinant of a matrix that obtain deleting third row, third column would be 2, 1, 0, 4, which is 2 times 4 gives me 8, minus 0 times 1, 0 times 1, so it would be 8. Now I substitute all the elements to corresponding place. That means element C11, I have to substitute it in the place row 1, column 1, so it would be 14. Keep going to substitute all the elements in this this matrix, so it would be C1, 2, so first row, second column, C1, 3, first row, third column, C2, 1, second row, first column, C2, 2, second row, second column, C2, 3, second row, and third column. Now I will go for the third row. C3, 1. Third row, first column, C3, 2. Third row, second column, and C3, 3. Third row, third column. It's a cofactor matrix of matrix A.